It's going to be simplifying variables that are underneath a radical. Okay, so let's take a look at that now. The even powers means that a variable is raised to an even number. These are the really nice ones to deal with when it comes to variables and radicals. Okay, for instance, x to the fourth, I need to ask myself, what times itself twice would give me x to the fourth? Well, x squared would. If I replace this question mark here with x squared, I would have x squared all raised to the second power, and we know by our power to power rules, 2 times 2, we would multiply exponents, would give me 4. Okay. Similarly, with the square root of x to the 16th, I would say, okay, well, what can I multiply by itself twice to get x to the 16th? And I would say, well, x to the 8th. Because x to the 8th here would give me 8 times 2, which would give me 16. So really, similarly with the last one, which is x to the 5th, what you can do with even powers is you can half the exponent, but it has to be an even power. So the square root of x to the 4th, half of 4 is 2. The square root of x to the 16th, half of 16 is 8. Square root of x to the 10th, half of 10 is 5. So if it's an even power, you can actually just take half of the exponent. Okay? For odd powers, it's a little bit different. We almost have to do what we were doing in the previous 5 or 6 questions. We have to factor this first. And all that we have to do is we need to factor just one x out of this starting radical. The reason is if you take one x out, you now are left with an even number. The square root of x to the 4th, we know that if it's even, all you have to do is half the exponent. So I would have x squared times the square root of x. Notice, once I evaluate the square root symbol with an even exponent, that radical is no longer there. Okay, so I would have x squared times the square root of x. This one stays because I actually can't simplify that any further. I can't simplify that any further. So for this one, very similarly, I need to take, it's an odd power, so I need to take one x out to give me an even power that I can actually work with. Well, the square root of x to the 10th would give me x to the 5th. It's an even power now, so I can half it. So I would have x to the 5th times the square root of x. Okay, so anytime we see an odd power, it's as easy as taking one of those out, x to the 7th here, for instance, take it out. Okay, that would give me the square root of x to the 6th times the square root of x. And then this one I can work with, right? Half of 6 is 3, so I would have x cubed times the square root of x. Okay, so if you are dealing with odd powers, you want to break off one factor, and then you want to square root the even power, because we know how to work with the even powers. They're nice to work with. The odd powers we can't do anything with. Okay, so your process when you have an odd power is almost exactly the same. You want to break off one and then square root the even power. And once you break off one, that one's going to kind of just hang around with the problem for the rest of it, because that's as simple as we can get it. Okay? So these are your kind of 2 rules, especially when variables are involved. So it's important we know these 2 rules. Even ones are the nice ones. Odd ones, we kind of have to do a step or 2 in order to get it fully simplified. Okay? Let's take a look at some TI-84 help here. If you guys set up your calculator and follow these steps, if you need to, you can pause the video. This will help you find perfect squares. Okay? So if you are interested in that, go ahead and follow these steps and play around with it a little bit, and that'll help you kind of find some perfect squares for numbers that you're not as familiar with. Otherwise, you can kind of guess and check and go from there. Okay? So if you need to pause the video, go ahead now, set up your calculator. Not everyone likes to use this. It is an option, though, if that's something you guys are interested in. Okay? For now, let's move on to example 4. We have 6 more of these problems we're going to do, and then a word problem, and then that'll be it for this lesson today. Okay? So when I take the part A of example 4, we're going to simplify these. I'm going to take the square root of x to the 8th, y to the 6th, okay, and they're both even, so it's as easy as just halving both exponents. Half of 8 is 4, so x to the 4th, and half of 6 is 3, so y to the 3rd. Okay, again, those ones are the nice ones because they're even. Okay, part B, I have the square root of 16x squared. First thing I need to do is I need to take the square root of 16. Well, hopefully we know at this point, because this one's kind of showed up a lot. The square root of 16 is 4. Okay, x to the 2nd power, even exponent, so I can cut it in half. Well, half of 2 is 1. So this simplified radical would be 4x. Okay. Part C, though, when we get to part C, it gets a little different. Okay, I have the square root of 525, x to the 4th, y to the 5th, z to the 5th. So now I have to work with this number and simplify it, right? My coefficient I have to simplify to pull out a perfect square. And then x to the 4th, that's already an even power, so that one will be nice. But I have y to the 5th and z to the 5th. So I'm going to have to do some work in this part here. Okay, my largest perfect square that goes into 525 is 25. So this first part here, 25 and 21, are coming from pulling out my perfect square factor of 525. So I would have the square root of 25 times the square root of 21. X to the 4th can stay the same, so the square root of x to the 4th. Y to the 5th is an odd power, so I have to pull out 1 and then square root the even one. So that's where the square root of y to the 4th times the square root of y is coming from. Similar to the z to the 4th and z. Okay, it originally starts as an odd power, so I need to pull one out, and then I can evaluate the remaining even power. Okay, so when I do this and simplify it, notice how all of my powers or all of my radicals that I can evaluate are going outside and in front of my expression. The square root of 25 is 5. Okay, the square root of 21 I can't do anything with, so it's staying underneath the radical sign here. The square root of x to the 4th is x squared, going outside and in front. Okay, the square root of y to the 4th is y squared, going outside and in front. Square root of y, I can't do anything with, so it's staying underneath the radical with 21. Square root of z to the 4th, again, even power now after taking one out. I can half it, z squared, stays out front with the rest of this stuff. So everything that you can evaluate is going to end up being out front of this radical expression, and everything else is going to go together underneath one radical sign. So the 21, y, and z that I can't do anything with, I can put under the same radical sign. Okay, so this would be my simplified expression for part C. Okay, part D, I have the square root of 147, x cubed, y to the 4th, z to the 5th. And once again, I'm going to have to pull out perfect squares of 147 and work with some variables too. So when I do that first step, okay, in this instance, the program is now showing you how you can put all of your nice, quote unquote, nice perfect square factors underneath the same radical instead of writing them all separately like we did here. Okay, this maybe is a better visual for some of us to show that this is the stuff that can be evaluated and this stuff can't. So 147, the highest perfect square that goes into 147 is 49. 49 times 3 gives me 147. So 49 goes underneath the nice radical. 3 goes underneath the unsimplified radical, or stuff that can't be simplified radical, I guess. Okay, x cubed, I have to pull out a factor of 1x, which is why 1 is over here, and the remaining are over here, x squared. Okay, y to the 4th is an even power, so it can go right to the one that can be simplified. And z to the 5th, I have to pull one out and put the remaining in that left radical. So everything in this left radical I can evaluate. The square root of 49 is 7. Square root of x squared is x. Square root of y to the 4th is y squared. Square root of z to the 4th is z squared. So all of that stuff I could evaluate, and I did. This stuff is as simple as it gets, so it has to stay underneath the radical sign together, giving me a final expression of 7xy squared, z squared times the square root of 3xz. Okay? So some of these problems, I think the biggest thing with these problems, guys, is identifying which ones and how to pull out your perfect square factors in order to be able to simplify them and actually evaluate the radical sign. Okay? Let's take a look at E. I have 2z times the square root of 300z cubed. Okay? So 2z is going to stay out front. And again, this is my radical here that can be evaluated. 100 is a perfect square that goes into 300. It goes into it 3 times. So 100 goes underneath the radical that can be evaluated. 3 goes underneath the one that can't. Okay? Z to the 3rd, it's an odd exponent. I pull out a factor and put the remaining even underneath my radical that can be simplified or evaluated. Okay? So I'm going to have 2z times 10z, because the square root of 100 is 10, and the square root of z squared is z, right? It's even, so we can cut it in half. Half of 2 is 1. And this one we don't do anything with. We can't simplify that at all. Okay? Now I can work with the stuff outside. If I take 2z times 10z, I would take 2 times 10, which is 20. And z times z, hopefully we remember from our exponent part of this module, is z squared. So I would have 20z squared times the square root of 3z as my final simplified expression. Okay? Looking at f, the last problem before the word problem here. I have 5y cubed times the square root of 432xy to the 7th. Okay, 5y cubed is going to stay out front. 432, the highest perfect square factor that goes into 432 is 144, and it goes into it 3 times. Okay, x, this solo x, I can't pull out a factor and still have even exponents remaining, so it's just going to go straight in to my other radical. Okay, y to the 7th, though, I can pull one out and put the remaining even in this radical. So I would have 5y cubed times the square root of 144 is 12, and the square root of y to the 6th is y to the cubed, or y to the 3rd, sorry, times 3x, the square root of 3xy. Now this stuff out here I can combine, right? 5 times 12 is going to give me 60, and y cubed times y cubed is going to give me y to the 6th power. So I have 60 y to the 6th times the square root of 3xy, right? This one, notice how it does not change throughout the whole thing here. Similar through all 3 of these problems. Once we got this radical here that we knew could not be simplified, it just kind of comes along for the ride. Okay? Hopefully that makes a little bit of sense. If not, feel free to rewind or pause and take a look at that. Okay? Let's take a look at our word problem here, finance. Sarah uses an online calculator to determine how much interest she would, I'm assuming that's supposed to be a cure. Sarah uses an online calculator to determine how much interest she would accumulate, maybe, I don't know, in a savings account after 2 years. I guess that's why I'm a math teacher, not a language teacher. Okay? She plans to invest $750, and the calculator determines that she could have $780 after 2 years. She can find the interest rate R of the savings account by using the formula R equals the square root of A over P minus 1, where A is the amount after 2 years and P is the initial investment. What is the interest rate? So we need to set this up, right? And we do that by saying R is equal to the square root of A over P. Well, A is the amount after 2 years. And the calculator determined that she could have $780 after 2 years. And P is the initial investment, which is $750. So I'd plug those numbers in. R is equal to the square root of 780 over 750 minus 1. And the first thing I want to do is reduce that as much as I can. So R is equal to the square root of 26 over 25 minus 1. Hopefully remember a problem like this earlier where we can actually split these apart into a square root of 26 in the numerator over the square root of 25 in the denominator. Okay, so I would have R is equal to the square root of 26 over the square root of 25 minus 1. Of course, we all know that 5 is a perfect square. So I would have R is equal to the square root of 26 over 5 minus 1. 26 has no perfect square factors that go into it. So that's as simple as that gets too. So all I need to do now is put this in my calculator and see what I get. Well, R is about equal to 0.02. Remember, interest rates are usually given in percentages. So hopefully maybe we remember how to convert this decimal to a percentage. We do it by multiplying by 100 to get the percent. So this decimal is actually going to move 2 spots to the right, giving me an interest rate of approximately 2%. Okay, so that's kind of a neat way to look at how we can use radicals and formulas in the real world and simplifying them in order to find things like interest rates and whatnot. Okay, so hopefully this helped. Hopefully you guys feel free if you want to rewind or rewatch some parts, talk to each other if you have any questions, and I'll be able to answer questions if you guys have any as well. Okay,